Waste is much fluffier now and has already 50% more heating value than unprocessed municipal waste. But direct burning would cause an excessively high contamination with the amount of heavy metals. The flammable materials must be separated from the remaining materials. The second core area of the dry stabilate method takes effect, the mechanical separation. Via conveyor, the dry waste is transported to the separating aggregates. In the disc screen, the first rough separation via fractioning by size is carried out. The individual material streams are then separated by their density into heavy and light fractions. The components of the incombustible heavy fractions with a density of more than 2 grams per cubic centimetre clearly stand out against the components of the inflammable light fraction, with a density of about 1 gram per cubic centimetre. Via density separation, the mixed stabilate may be freed from nearly any incombustible components, inert materials and metals. This material separation is carried out for various sizes in pneumatic ore processing tables and air separators. Light materials such as paper, wood, plastics and textiles are separated via air streams from heavy inert materials such as glass, ceramics, stones and metals. Some material streams are separated into even smaller sizes in order to obtain a more effective density separation. This happens via shaking screens. Light and heavy fractions that are bigger than 35 mm are post-chopped in addition. From the light and heavy fractions, metals are sorted out by 2 methods. Ferriferous metals, such as steel and cast iron, of the individual material streams are separated into an additional material stream via magnetic metal separation. In eddy current separators, anti-magnetic but electrically conducting metals such as aluminium and copper are separated via fast rotating magnets and may thus be carried back to industrial use. In the complex combination of different materials, there are always composite materials that may not be separated by this method. This group of materials contains first of all batteries and chlorous plastics. As they would damage the environment by being burnt or being deposited unprocessed, they have to be sorted out by hand and disposed of in a special way. Dry waste, mechanical shaking and conveyor movements produce a high amount of dust in the plant's closed aggregates. In the residual waste treatment plant Niederlehmer, this dust is sucked off, filtered and mixed with the dry stabilate. At the end of this biological and mechanical process, the usable materials, such as plastics, paper and wood, may be converted to a high-quality fuel, the dry stabilate. In pellet presses, it is slightly pelletized or processed into pellets. Trucks transport it for energetic utilization to industrial power plants. Right from the beginning, ZAB has supplied brown coal power plants. The secondary fuel may also be used in the cement industry. Secondary fuels produced by ZAB in the Niederlehmer plant have an outstanding energetic and environmental balance. The pellets produced in Niederlehmer have the same fuel features as brown coal: high heating value, low heavy metal contamination, high storage stability and a uniform structure. It is thus possible to integrate secondary fuel into a flexible energy supply. The door for a compelling connection between waste management and power industry has been pushed wide open, and the Waste Treatment Association Nuterspray keeps this door wide open. The residual waste treatment plant of ZAB in Niederlehmer is an example for how waste management and power generation may be designed in an environmentally friendly way. Looking forward, ZAB has invested in the future of the environment and the region by building this plant, so that pine woods, lakes, small hills and picturesque avenues will remain a special feature of the Brandenburg countryside.